Hyperledger Fabric is designed for collaboration among known organizations. Its architecture separates identity, trust, transaction ordering, and ledger storage, so enterprises can share data with confidence while still controlling who participates and how transactions are validated. We've seen why enterprise blockchain needs a modular, permissioned approach. Now we'll look at the main components that make a Fabric network run and then connect them into the flow of a transaction. A Fabric network works because each component has a clear role. Organizations bring participants and define trust boundaries. Certificate authorities and MSPs establish identity. Peers run smart contracts, endorse proposed transactions, and maintain ledgers. Orderer nodes create a shared transaction sequence so peers can commit consistently. Governance policies connect these pieces by defining who can join, endorse, update configuration, and operate the network. A Fabric organization is a trust domain that usually maps to a real enterprise participant, such as a company, regulator, university, bank, or department. Each organization controls its own identities, administrators, peers, and operational responsibilities. Instead of relying on one central operator, Fabric represents each organization through an MSP, then uses network policy to combine those definitions. This turns legal agreements and consortium governance into enforceable technical boundaries. An MSP is the trust definition for an organization. It does not create identities itself. Instead, it determines which certificates are valid based on trusted certificate authorities. When a user, peer, orderer, or application connects, Fabric checks that identity against the relevant MSP. This is how the network separates organizations, recognizes administrators, and enforces channel access. In practice, most networks have multiple MSPs, typically one or more for each participating organization. Administrative authority in Fabric depends on both identity and policy. An admin certificate proves who the actor is, but policy decides whether that actor may perform a specific action. For example, updating channel configuration may require approval from a majority of organizations, while chain code approval may require designated organization admins. This separation prevents a single credential from becoming unlimited power and gives enterprises clear, auditable control over sensitive operations. Peers are where much of Fabric's work happens. A peer can maintain a channel ledger, including the full block history and the current world state. As an endorser, it runs chain code to simulate a proposed transaction and signs the result. After ordering, committing peers validate blocks, apply valid transactions, and update the ledger. The same peer can play different roles on different channels, depending on how the network is configured. For every channel it joins, a peer keeps a separate ledger. That ledger has two views of the same truth. The blockchain is the permanent history, ordered blocks of transactions, including transactions later marked valid or invalid. The world state is the current snapshot, stored as key value data for fast reads. LevelDB is simple and embedded, while CouchDB supports richer JSON queries. Applications usually read the world state. Audits rely on the blockchain history. Endorsing peers act as transaction simulators, while committing peers act as ledger guardians. Endorsers run the chain code first, produce a read-write result, and sign that result. The ordering service then packages submitted transactions into blocks. Committing peers do not rerun the business logic. They check endorsements, detect version conflicts, and update the ledger. This separation is what makes Fabric's execute, order, validate model scalable and deterministic. Once a transaction is endorsed, it is still not committed. The client application submits a transaction envelope to the ordering service, which creates one shared sequence for the channel. Orderers batch transactions into blocks and deliver those blocks to peers. They do not run chain code, evaluate business rules, or decide whether updates are valid. By keeping ordering separate from endorsement and validation, Fabric stays modular while ensuring every peer receives transactions in the same order. Ordering nodes are valuable only when they agree on one transaction sequence. Consensus gives the ordering service a consistent block order, so peers receive the same blockchain. In many Fabric deployments, Raft provides crash fault tolerance using a leader, followers, and quorum. A single orderer has no high availability. 3 nodes can tolerate 1 failure, and 5 can tolerate 2. They should be spread across failure domains, because if block delivery stops, transaction processing stops. Designing the ordering service means deciding where trust and operational responsibility belong. A single operator may simplify management, while shared operation may better match consortium governance. Production networks also need orderers distributed across zones or regions, with quorum, certificates, backups, and recovery planned early. Channel participation affects who can use and configure ordering resources. Ongoing monitoring matters too, because ordering latency, throughput, and failures directly affect transaction reliability. Fabric identities begin with a trusted certificate authority. An administrator registers an identity, and enrollment issues the certificates and keys that entity uses to sign requests and prove who it is. That entity may be a user, admin, peer, orderer, or application. Fabric CA can provide this service directly, or an enterprise CA can integrate with it. Over time, identities need renewal, and if trust is lost, they must be revoked. Identity management is an ongoing operating process, not a one-time setup. If a supplier admin leaves or an account is compromised, the certificate must be revoked quickly. The MSP uses a certificate revocation list, or CRL, to reject that identity across the network. Many enterprises connect Fabric to an external CA, so revocation, renewal, audit evidence, and compliance controls follow the security processes the organization already trusts. You now have the core map of a Fabric network. Organizations define trust. MSPs and CAs manage identity. Peers run chain code and maintain ledgers. Orderers sequence transactions. Next, we'll connect these pieces in motion by following a transaction from proposal through ordering to final commitment.